and welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over solving equations and more specifically multi-step equations. So we're going to see distribution, variables on both sides, but it's important that we have that knowledge of one and two step equations because we are going to be hitting those steps. So once we do our distribution of variables on both sides, we always end up with our two-step and one-step equations. So if we're not proficient in that, we are going to struggle. So hopefully before we get to these problems, we have a great understanding of our one-step and two-step equations so we're able to continue. But let's look at a problem and see how we would solve it. So I have this problem here. And what's important here is to see what are we having to do to get that variable by itself. Well, this variable is a term. This has one term that's together. We need to move all the other terms to the other side to be able to then work with that variable term. So to be able to move that -5 over, I can't just pick it up and throw it over here. I can't just do -6 minus 5. I have to have a balanced equation where I'm going to have to use my inverse operations, and I'm going to add 5 to this side to get rid of it. It cancels it out. But if I'm adding 5 to this side, I have to add 5 to this side as well. So -6 plus 5 gives me -1 equals v divided by 12. And as you can see, knowing our information on integer operations is very important because if we do -6 plus 5 and get the wrong answer, we are going to mess up this whole problem. So I need to know that -6 plus 5 equals -1. Now we have a one-step equation, and looking at this, we have our v and our 12 glued together with division. We need to unglue that, and to do that, we use our inverse operations again. So the inverse operation of division is multiplication. So I'm going to multiply by 12 on both sides. That cancels the 12s out, and I'm left with v by itself. I can do 12 times -1, which is -12. That equals v. And I am done with my problem. But like I said before, we are seeing problems where once we get to the first step done, we are left with either a one or two-step equation. So it's important we know what that next step is. Let's take a look at another problem that has a division fractional problem and see how we would solve that one too. So now we have this problem, and instead of being able to just move the 4 over, the 4 is in the term with our x variable. So we can't do anything because they're both glued together, again, by division. So to be able to unglue them, we need to use our inverse operation. So to get rid of the division of the 8, we multiply both sides by 8. And this is not saying we need to multiply the numerator by 8, leave that there, and then the denominator goes away. This is saying this cancels out. We can multiply everything in the numerator by 8, but then we need to divide it by 8 because that 8 is in the denominator. So once I cancel that out, I'm left with 8 times 3, which is 24, equals 5x plus 4. We're at our two-step equation, so we need to know once we get to this step that we need to get the x term alone. So I'm going to move over our constant here. I get 24 minus 4, which is 20, equals 5x. We're at our one-step equation. We do the opposite of the multiplication, which is a division of 5, and we get x equals 4. So there was a slight difference here between the last problem and this problem, where we had to, instead of moving over first, we're multiplying first to get rid of that division problem. Let's take a look at another problem where we're a little bit stepping it up to see what has to happen there. So now we have this problem here, and it might seem a little scary. There's a lot going on here, but I'm giving you this problem so you can see when we have distribution, variables on both sides, what we have to do. We need to go through all these steps. So if I give you variables on both sides, you will start at that step and keep on going. So this has everything in it, so you're able to solve any problem that's given to you. So here I'm going to leave the 6 where it is. I'm going to do -3 times -7, which is positive 21p. I'm going to do -3 times 8, which is -24, equals 6p stays the same. Here is a little bit of a complex understanding sometimes for my students. We have a negative here. This is not saying we're subtracting all this. Technically it is, but we need to remember that we're subtracting the p and the 2. So we need to distribute in that negative sign, which is the same as distributing in the -1. So I do -1 times p, -1 times 2, which is -p minus 2. Now I'm left with the variables on both sides, but I can't just fully do my variables on both sides steps because I need to combine my like terms just so that there is a variable term, a constant, a variable term, a constant, just to clean it up a little. So I'm going to use my combining like term skills. So I'm going to see on this side, we have a 6 and negative 24 that are my constant terms that I can combine to clean this up. This is not saying I'm using my inverse operations. We're not moving it over. They're on the same side, so we just combine them. So I get 21p minus 18, so that's 6 minus 24, equals, on this side, our 6p and our negative p combined to give me 5p minus 2. Now we have the variables on both sides, but we're going to be moving things to the opposite sides to be able to get the variable alone and the constant alone. So the way I always like to think about it is, which variable term is the smallest one? 21p or 5p? 5p is smaller, so I'm going to use my inverse operations to move it over. So I'm going to subtract 5p from both sides, and I get, I'll bring it over here, 16p minus 18 equals negative 2. These canceled out. This gave me 16p minus 18 equals negative 2, just so we can see it a little bit more clear. Once we get here, we have our two-step equation. So I need to get that variable alone. So I'm going to add 18 to both sides to move it over. And I get 16p equals 16. Sometimes this is a little bit confusing for some students where we're like, okay, we have a 16 and a 16. Is that one of my special cases? No, it's not going to be one of my special cases because I can still divide by 16 and I have that variable there. So when I divide by 16, 16 divided by 16 is 1. So I get p equals 1. So that was a lot in one problem, but it's showing you that you can do any step within each other. So once I distributed, I had variables on both sides where I had to combine. I had a normal variables on both sides, two-step equation. So if I just threw a problem at you that started here, you'd be able to solve it because you have all that understanding from here down. Let's see another problem that's similar to make sure that we're clearly understanding this problem. Now we have this problem, and it's similar to the last one in the sense we have distribution, variables on both sides, but instead we have two distributions on one side. That's no big deal though. We know how to distribute, so we can solve this problem. So I'm going to distribute 2 times 3b gives me 6b. 2 times 3 gives me plus 6. Negative 2 times 5b is negative 10b. Negative 2 times negative 3 is plus 6. And everything on my right-hand side stays the same because I can't combine any like terms or distribute there. There's nothing else there to work with. When I look at this left side, though, I can see I can combine my like terms, so I'm going to do that to clean it up. So I have 6b and negative 10b and 6 and 6 that are like terms. So 6b and negative 10b is negative 4b. 6 and 6 gives me plus 12 equals negative 4b plus 12. Now we look, which variable is the smallest term? Negative 4b and negative 4b are the same, so I'm going to just choose one to move over. So I'm going to add 4b to both sides. And it cancels both of them out. You're not left with any b. Negative 4 plus 4 is 0. There's nothing left, no more variable. So I am left with 12 equals 12. And we have to think here, our variables canceled out. Does 12 equal 12? Yes. So the answer is going to be infinite solutions. Some books like to call it all real numbers. That's okay if you put all real numbers. It's the same concept. However, what if this was a 14? For some reason, I got 14. The problem gave you 14. If this was 12 equals 14, however, that'd be no solution. My variables cancel out. I'm left with two constants that do not equal each other. It does not make sense. 12 does not equal 14. My answer would be no solution. So I wanted to show you a problem where we would have one of our unique cases where we have an infinite or no solution. Let's try one more problem just to make sure we're seeing all the different types that might give us some challenges. So now we have this problem, and this problem sometimes looks a little bit scary because we're working with fractions, variables on both sides. A way I like to do this though, to avoid the fractions, is we're going to multiply everything by some number. And I'm going to give you a different type of problem in the sense that not both terms have the fraction. Maybe the constant will be the fraction. Well, anytime we have these types of fractions, it's the same step. So it doesn't matter which numbers are the fractions. We're going to be applying the same knowledge. So I have a -1/5 and a 4/5. Every time we're going to look at the fraction. What I like to look at is, what is the biggest denominator? And maybe the biggest denominator is not going to help me. I want to find the number that's going to be able to multiply everything by to get rid of the fraction. The ones I give you personally will always be the biggest denominator, but sometimes, let's say if you have an 8 in the denominator and a 5, you'll have to multiply everything by, let's say, 40 to cancel out those fractions. In this case, both denominators are the same, so I'm going to multiply everything by that denominator. So I'm going to multiply everything by 5 because I want to get rid of these denominators. So 5 times 4/5 gives me 20 divided by 5, which is 4D. 5 times 3 is 15. 5 times -2 is -10. And 5 times -1/5 is -5/5 D, which is -D. You need to multiply each term by that 5. We're using our distribution again in a sense because we are distributing it to each term here. Now we have the variables on both sides and no fractions. The no fractions part is the best part about this. I'm going to pick which one's my smaller term for my variable, the -D. So I'm going to add that over to move it. And I get 5D plus 15 equals -10. I'm going to write it over here just for more room. We have a two-step equation. Let's get our variable alone. So I'm going to subtract 15 from both sides. We have our two-step equation. And I get 5D equals -25. One-step equation, divide by 5. And I get D equals -5. So I am hoping after all these problems, we are able to see that these might look scary, but we're doing the same processes almost where we're using distribution, variables on both sides, one and two-step equations. It might be a lengthy process, but with all our knowledge, we'll be able to solve these like pros.